This is Lesson 10, Exponential and Logarithmic Functions. We've talked a lot about solving equations, solving for variables where a variable is part of an equation. However, what we have not talked about is how do you solve it if the variable happens to be an exponent? This would simply be called an exponential function. A general example of an exponential function might be a to the x equals b, where x is your variable or unknown and a and b are real numbers. So here's a fairly simple example. 2 to the x is equal to 8. What is x equal to? Well, I think you basically know that x is going to be equal to 3. But how do we go about doing this mathematically? What are the steps involved? Well, what we first must do is must change 8 to being 2 to a power. Now obviously 8 is equal to 2 to the 3. Now, we have the same number raised to different powers, so now we can set the powers equal to each other. And once we do that, we get the answer x is equal to 3. So let's look at a little bit more complicated example. What if I had 5 to the 4 minus t is equal to 25 to the t minus 1? Well, first of all, I got to get the base numbers, and what I mean by base numbers is the 5 and the 25 to be the same number. Well, I happen to know that 25 is 5 squared. So what does that leave us with? So that brings us to 5 to the 4 minus t is equal to 5 squared, but that whole thing raised to the t minus 1. So remember the laws of exponents. We're going to multiply these exponents on the right-hand side, and let's see what we get. So now we have our base numbers the same, 5, so we can simply set the exponents equal. And now we can simply solve for t. And we get our final answer of t is equal to 2. So what do you do if you can't get the base numbers equal? How are you going to solve an exponential function where you can't get the bases equal, so you set the exponents equal? Well, several mathematicians looked at this in the early days and decided to come up with something known as logarithms. So what exactly is a logarithm? So a logarithm is basically defined as, if you've got an exponential function a to the x equals b, then that is equivalent to the log to the base a of b is equal to x. So as you can see here, when your variable is the exponent, you can solve for it by using this new function referred to as a logarithm. So now let's look at one of the examples that we talked about earlier in this lesson. Let's say we've got 2 to the x equals 8. Now I could rewrite that as a logarithm as simply log to the base 2 of 8 is equal to x. Now, how do we find these logs? Log tables are located in textbooks. You can get log tables there, or you can use them. Most scientific calculators will have the log function on it as well. So if you were to plug in log to the base 2 of 8, you would find that that is equal to 3, just like we did in the previous exponential function example. Now, to understand logarithms even further and to be able to use them, you have to know and understand various laws of logarithms. The first of these is the product rule. If you've got the log of a product, it's equal to the sum of the logs of the individual factors. For example, the log to the base b of m times n is simply equal to the log to the base b of m plus the log to the base b of n. Or if we were to use numbers, the log to the base 2 of 5 times 10 is equal to the log to the base 2 of 5 plus the log to the base 2 of 10. The next law is the quotient law, and this simply says that the log to the base b of m over n is equal to the log to the base b of m minus the log to the base b of n. An example using numbers might be log to the base 2 of 10 over 5 is equal to the log to the base 2 of 10 minus the log to the base 2 of 5. Now the last of these basic laws of logarithms is the power law or power rule. And this says that the log to the base b of m to the k is simply equal to k times the log of b to the base b of m. So whatever that exponent is, you simply move it out front of the log and multiply it, and that is the basic law or power law of logarithms. Now, in addition to these laws, there's a couple identities you need to be aware of. And that is, for example, if we had the log of b to the base b, it's simply equal to 1. Now, if you think back to the basic definition of logs and converting a log to an exponential, this is simply saying b to the 1 is equal to b. And that's obviously true, so therefore the log of b to the base b is equal to 1. And the second of these is that the log to the base b of 1 is equal to 0. And again, if you would convert this to the exponential form, you would simply have b to the 0 equals 1, which is obvious. Any number to the 0 power is equal to 1. Now, knowing these laws and identities, we can do certain examples. So if we were asked to solve this, 2 log base 10 of 5 plus log base 10 of 4, first thing we would do is try to get it into a single log. And using the laws of logarithms, it would look something like this. So if you follow all the steps and use the various laws of logarithms, an expression that seemed rather obscure to begin with ends up being fairly simple, with the answer being 2. Another example might look like this. Log base a of x is equal to 2 log base a of 3 plus log base a of 5. Solve for x. Well, on the right side, we can combine that into a single logarithm. So using the power rule, we can move the 2, that's right here, we can move that to an exponent there. That makes that 3 squared, but then we got the sum of 2 logs, which is the law of the product. Now, once we got a single log equaling a single log, we can cancel out the logs and simply end up with our final answer, which is x is equal to 45. So now move on to the worksheet. As I said, always try to do the problems without looking at the answers initially. If you have any questions or problems, be sure to post them on the discussion prompt. And once you have completed that, try the mastery quiz and see how you do.